Right now, engineers are preparing to build a power station so massive it will cover 15,000 square kilometres, an area larger than the entire country of Wales. This involves 60 million solar panels and 3,000 wind turbines that will stand taller than skyscrapers. Australia is quietly building the invisible backbone of the future world, using billions of tons of steel and concrete. How do you build a cable long enough to reach from Darwin to Singapore under the deep ocean, and what happens if it breaks? Let's dive into these 8 Aussie mega infrastructures that you have never heard of. The Cape Hardy Green Hydrogen Project. On the eastern coast of the Eyre Peninsula in South Australia, a giant industrial hub is taking shape. This is the Cape Hardy Green Hydrogen Project. The goal here is to use the massive amounts of sun and wind in the region to make a clean fuel called green hydrogen. To do this, engineers plan to build an electrolyzer facility with a capacity of 5 gigawatts. Think of an electrolyzer as a giant machine that uses electricity to split water into hydrogen and oxygen gas. Because the power comes from wind and sun, the fuel is completely clean. The facility is expected to cost around $35 billion and will create 5,000 jobs when work is at its busiest. The technical design of the port is what makes this project special. It is a naturally deep water port, which means the water is deep enough for the world's largest ships, called Cape-size vessels, to pull right up to the jetty without any digging or dredging. The port precinct covers 1,207 hectares. To make the fuel, they need water, so they are building a desalination plant to take the salt out of ocean water. This hydrogen will not just be exported, it will be used to make green iron pellets from the local magnetite ore reserves, which total 3,700,000,000 tonnes. Construction of the first parts should begin soon, with full production planned for the second half of the year 2031. But even as we turn water into fuel, how do we send electricity across the ocean to a different country? Australia-Asia Power Link. The answer lies in the Northern Territory, where the Australia-Asia Power Link is being developed. This project aims to build the world's largest solar farm at Powell Creek on 12,000 hectares of land. That is roughly 17,000 football fields covered in solar panels. This giant array will generate between 17 and 20 gigawatts of power. To make sure the lights stay on even when the sun is not shining, they are building the world's biggest battery, which can store between 36 and 42 gigawatt hours of electricity. This is enough to power millions of homes. The real engineering magic is the cable. First, an 800-kilometre overhead line will carry the power to Darwin. From there, it enters a 4,300-kilometre undersea cable that travels all the way to Singapore. This will be the longest undersea power cable on Earth, 5 times longer than any other. It uses high-voltage direct current technology, or HVDC, which lets electricity travel huge distances without losing much strength. The project has a massive cost of $35 billion. While it hit some money problems in the year 2023, a new group of owners has taken over and intends to have it powering Darwin by the year 2030. If we can send power to Singapore, can we build something even bigger that produces enough energy for all of Australia? Western Green Energy Hub. In the far southeast of Western Australia, on the Nullarbor Plain, engineers are planning the ultimate energy project. The Western Green Energy Hub covers 15,000 square kilometres of land. This is a massive area owned by the Mirning people, who are partners in the project. The plan is to reach 70 gigawatts of power capacity, which is about the same amount of electricity the entire country of Australia uses today. To reach this goal, they will install 3,000 wind turbines and 60 million solar panels. The project is estimated to cost $100 billion. The engineering uses a nodal design. Instead of one big power plant, they are building 35 separate clusters called nodes. Each node has 2 to 3 gigawatts of wind and solar power, wrapped around a 1.5 gigawatt electrolyzer. This keeps the electricity lines short and efficient. The hub will produce 3,500,000 tonnes of green hydrogen every year, which can be turned into 20 million tonnes of green ammonia for export. Because the site is so far away from everything, they will manufacture the steel towers and turbine blades right there on the land. It will take 15 years to build the whole thing, with the first production targeted for the year 2032. But while we look to the sky for energy, what secrets are hidden deep in the red dirt of Victoria? Donald Rare Earth and Mineral Sands Project. Deep under the farms near Minyip in Victoria, a giant deposit of 2,400,000,000 tonnes of ore is waiting to be mined. This is the Donald Rare Earth and Mineral Sands project. It is not a typical mine. It will produce rare earth elements like neodymium and praseodymium, which are used to make the magnets in electric cars and smartphones. The engineering team is using a moving hole technique to protect the land. They divide the site into blocks that are 500 meters wide and 250 meters long. They mine one block and immediately start putting the dirt back to fix the soil, so farmers can plant crops again within a few years. The mine will be 23 meters deep and will run 24 hours a day for 42 years. It is expected to cost $439 million. There has been some controversy because these sands contain tiny amounts of uranium and thorium, which can be radioactive. However, the engineers have shown that the levels are 18 times lower than government safety limits. To keep the local community safe, they use a wet mining process that uses water to stop any dust from blowing away. Construction is set to begin in the year 2026, with the mine creating 600 local jobs. If we are digging up all these minerals, how do we get them to the ocean without using thousands of trucks? Surat Basin Railway. The Surat Basin Railway is the answer to moving massive amounts of cargo through Queensland. Often called the Southern Missing Link, this project is a 210-kilometre freight rail line. It connects the Western Railway near the town of Wandoan to the Mora line near Banana. The most difficult part of the engineering is the Downfall Creek Bridge. This structure will be 415 metres long and 50 metres high, which is as tall as a 15-storey building. It will take 30 months just to build this one bridge. The railway is designed to carry trains that are 2.5 kilometres long. To keep the path flat for these heavy trains, workers must move 12 million cubic metres of earth. The tracks use continuously welded rail, meaning there are no gaps between the metal pieces, which makes the ride smoother and quieter. While it was originally supposed to cost $1 billion, the price has recently exploded to over $19 billion due to changes in the economy and design. The line is built to be flood immune, meaning it can stay dry even during a 1 in 100-year flood. Once it is finished, it will move 42 million tonnes of coal and freight every year. But when these giant ships arrive at the coast to pick up the cargo, how do we fix them if they get damaged? Northern Marine Complex and Darwin Ship Lift. In Darwin Harbour, a giant elevator for ships is being built. This is the Darwin Ship Lift, the centrepiece of the 246-hectare Northern Marine Complex. A ship lift is a massive platform that lowers into the water. A ship floats over it, and then powerful electric winches lift the platform and the ship straight up into the air. This lift will be 103 metres long and can handle vessels weighing 5,500 tonnes. This is big enough for Navy ships and large fishing boats. The engineering includes a 10.3-hectare hard stand area, which is a massive concrete floor where ships are parked for repairs. To move the ships from the lift to the repair sheds, engineers use self-propelled modular transporters, which are giant trailers with hundreds of wheels that can carry thousands of tons. This project has been very controversial because the cost has ballooned from $100 million to $820 million. The government is paying for it, but a private company will run it for profit. Construction started in April of the year 2024 and should be finished by March of the year 2027. As we build bigger ships, we also need new high-tech materials. Could a new factory in Queensland be making the secret ingredient for the world's fastest computers? Alpha HPA Ultra-High Purity Alumina Facility. In Gladstone, Queensland, a company called Alpha HPA is building a world-scale manufacturing plant. They are making a material called high-purity alumina, or HPA. While most aluminum is used for cans or cars, this material is refined until it is 99.999% pure. Engineers call this 5 nines purity. This ultra-pure powder is a miracle material because it can move heat away from computer chips very fast, but does not let electricity leak through. This makes it perfect for the AI data centers that run our internet. The facility uses a world-first process called SmartSX. Instead of melting aluminum at 2000 degrees Celsius, which uses a lot of energy, they use a chemical process to pull out the pure aluminum ions like a scientific scalpel. The plant is powered by 100% renewable energy and has almost zero waste. The facility is expected to produce 10,000 tons of HPA every year. Alpha HPA has raised $590 million for this second stage of the project and expects it to be fully operational by the year 2027. It will create 420 jobs during construction. But if we have all these green factories and solar farms, how do we keep the grid steady when the wind stops blowing? Port Augusta, Northern Battery. The final project on our list is a symbol of how Australia is changing. In Port Augusta, South Australia, an old coal power station is being reborn as a clean energy hub called the Northern Battery. This is a 270 megawatt battery project that can store 2,160 megawatt hours of energy. What makes this battery special is its duration. Most batteries only last for an hour or two, but this one provides 8 hours of storage. That is enough to power 300,000 homes for a whole night. The engineering secret is grid-forming technology. Usually the power grid needs big, heavy spinning machines to stay steady. This battery uses smart inverters to act like those old machines, keeping the voltage and frequency of the electricity stable. By building it at the site of the old Northern Power Station, the engineers can use the existing power lines and substations that are already there, which saves hundreds of millions of dollars. The project will cost around $400 million and is expected to start construction in the year 2026. It is the final piece of the puzzle that will help South Australia reach its goal of being 100% renewable. If you want to see more of these engineering wonders, make sure to like the video and subscribe to the channel. Don't forget to comment below and tell us which project you think is the most impressive, and turn those notifications on so you never miss a story. See you in the next one.